And in the vector calculus, in the last two lectures, we have discussed about surface integral, and that is very important because surface integral will be used for the proof of a divergence theorem and Stokes theorem. We must know how to apply the surface integral and how to evaluate the surface integral. Related to surface integral, we shall.
सर स्क्रीन शेयर नहीं सर
हाँ जी,
स्क्रीन नहीं दिखा रहा
स्क्रीन शेयर नहीं हो रही।
हाँ जी सर
अच्छा, दोबारा देखिए, अब देखिए।
हाँ जी सर अब शेयर हो गया
Okay, we have to evaluate the surface integral f dot n cap ds over the surface S. The vector f is given to us, that is yz I cap and zx j cap plus xy k cap, and S is the part of the sphere. Sphere is x square plus y square plus z square equal to 0, lies in the first octant. We have to take the part of this sphere which lies in the first octant. First octant means first quadrant, in which all the variables will be positive. And clearly, what we have to do, we have to find out ds now. And ds accordingly we shall find that will be dx dy and k cap dot n cap will be there. And n cap we need to find out. N cap will be equal to the vector n into denominator its magnitude. And what will be the vector n? Vector n will be the gradient of this surface. That will be named as phi. Phi will be named as x square plus y square plus z square minus 1 equal to 0. And n will be named as grad phi divided by its magnitude. And grad phi is always a vector, so that will be 2xi cap, 2yj cap, and 2zk cap divided by its magnitude, mean coefficient of I cap square, 4x square, 4y square, and 4z square. And what will be this in the denominator? In the denominator 4 is common, and square root of 4 will be 2, and that 2 will be cancelled with this 2. Ultimately what we have, this one, xi yj zk divided by 2 square root of x square plus y square plus z square equal to 1 is not there. We are not studying it. This is x square plus y square plus z square. 2 will be cancelled, and this is the equation of a square. Its value is given as 1. So square root of 1 will be 1. So this is your n cap vector xi plus yj plus zk. Now what we have, we can find out k cap dot n cap now. K cap dot n cap will be z. You can check. And f dot n cap should be equal to, what is n cap? N cap is xi yj zk. So that will be yzi plus zxj plus xyk dot product xi yj plus zk. You can evaluate the dot product and it come out to be 3xyz. You can see now. This can be written, evaluate over this, that is 3xyz, that will be dx dy over z, because its value is z, and z modulus square will be there, so z will be cancelled with that. This you need to evaluate. 3 is a constant, can be taken out, that will be xy dx dy over this x square plus y square is equal to 1, because we are taking in the first octant with the xy plane. So in xy plane z is 0. So you will take z is 0 here. So you will left with the circle only, x square plus y square equal to 1. And we know that the parametric or polar equation of a circle R, put x is equal to r cos theta. What is the r? 1. R is the radius here. So put x equal to cos of theta and y equal to sine of theta. And we will be able to find out the dx dy. And the dx dy is actually the Jacobian. Jacobian J will be dx dy. And how to find out Jacobian? Del x by del r and del x by del theta, del y by del r and del y by del theta. This is the way to find out Jacobian. You can take r here. So the derivative of x with respect to r cos theta with respect to theta minus r sin theta with respect to r sin theta and with respect to theta, that is r cos theta. This is the way to find out Jacobian. When you expand this, you will have this value r into cos of a square theta plus sine of square theta. So this value is 1. So this is r. Jacobian is r. So ultimately you can put the values. So the value of x is r cos theta and r sin theta. So r square cos theta sin theta and dx dy will be substituted as r dr d theta. So this is the way to substitute. And what it come out to be now, you can integrate it. This is okay. We have to take the limits of r and theta. In this circle, r varies from 0 to 1. And because we are taking the first octant, in the first octant, theta always be from 0 to pi by 2 in the first quadrant. First quadrant when we make, this is the way to make quadrant. And in quadrant, this angle, this is the first quadrant, angle is always 90 degree. So that will be 0 to 90 degree. Now you can integrate it, and this come out to r square into r cube will be there. So you can integrate r4 over 4, 0 to 1, and that is 0 to 5 by 2. And this is 1 by 2. You can multiply it with 2. So 2 sin theta cos theta will be here. Multiply with 2 divided by 2, because its formula is sin 2 theta. So what it come out to be, that is 3 by 8, and the integration of sine is minus cos 2 theta over 2, that is 0 to 5 by 2. So you can put the limits now and check. This come out to be minus 3 by 60 for upper limit, that is cos of pi, and for lower limit, that is cos of 0. And cos pi is clearly that is minus 1 and cos 0 is 1. So minus will be adjusted over here. So ultimately you will have 3 by 8. So this is your surface integral in this case. Always try to convert when we have a 3D figure into polar form, because in polar form we always be able to find out in a very easy way. Now, after surface integral, we should do 2 questions related to triple integral or volume integral. Triple integral is also said to be the volume integral. If we are saying volume, then obviously we are talking about 3-dimensional surfaces. like sphere, like cylinder, or any other 3D surface. Question is, they are saying that evaluate phi dV now, because this is the volume integral, and phi is given to us, that is 45 x square y, and capital V is the closed region bounded by the planes x0, y0, z0, clearly in positive octet. 4x plus 2y plus z is equal to 8. This is the equation of a tetrahedron. So we have to evaluate this, and it is clear. Triple integral, the value of phi is 45 x square y, dv is dx, dy, dz. This is the meaning of dv, dx, dy, dz. The question is how to write down the limits. Clearly, the lower limits of all the three variables x, y, z is 0. So 0 is the lower limit in all the cases. Ultimately, first of all, you can find out the limit. That is very easy. The z come out to be 8 minus 4x minus 2y, because these two terms can be taken to the right. So you can write down the limit of z. So this is the limit of z. So this is z is equal to 0 to this. Then we have, for finding out the other two limits of x and y, we need to take z as 0. So if you take z is equal to 0 in this, you will have 4x plus 2y is equal to 8. So 2 will be cancelled throughout. 2x plus y equal to 4. And from this, y will be equal to 4 minus 2x. It is very easy. So this is the limit of y. And at last, we need x. And for x, we need z0, y0. So ultimately, 4x is equal to 8 and x is equal to 2. So this is the procedure to find out the limits. So if the limits of z in the other two variables is written first, then you need to write z here. What does it mean? If you write dz here, it means you have to integrate it with z first. So it can be written 0 to 2, 0 to 4 minus 2x. Now these are the limits of z. So 45 x square y, because it doesn't contain any z. So integration of dz is z. 0 to, limits can be substituted, 8 minus 4x minus 2y. So you can substitute the limits now, the upper limit and lower limit. So 0 to 2, 0 to 4 minus 2x, that is the 45 x square y. Put upper limit here, 8 minus 4x minus 2y, that is dy dx. Now, you know that we have to integrate with respect to y, because the limits of y are in x. So this is the pattern we have to follow, because we have taken the limits in this sequence order, that you have to integrate with the z first, then with respect to y, then with respect to x. So 0 to 2, substitute, integrate with respect to y, that is 45 into 8, that is 360 x square y square over 2. All the integration of y will be y square over 2. Limits will be substituted at last, and that will be minus 4xy, and that will be minus 2. You have to multiply here also. 45 into 4, that is 180, that is x cube. Integration of y will also be y square over 2, and that will be 90 x square, that will be y square, that will be y cube over 2. That will be 0 to 4 minus 2x. Now, after substituting the limit of y, in place of y, you will substitute 4 minus 2x, and then at last you will integrate it with respect to x and get the value. So, cancel the terms which are easy to be cancelled. This is 90 and this is 30. You can substitute the limits and then integrate it with respect to x. So this is the procedure to evaluate a triple integral or a volume integral. Related to volume integral, we have one more important question. This is also very will be helpful in future because we have to use it in the theorem. Question is, the vector f is given to us, that is 2x square minus 2z I cap minus 2xy j cap minus 4x k cap. Now you need to evaluate curl f, because curl f is always a vector quantity, and curl f dv we need to calculate. You know that in place of curl f we can also write down del cross f. Both have same meaning. And what is capital V? V is the region bounded by the planes x0, y0, z0, and 2x plus 2y plus z is equal to 4. So this is the equation of a tetrahedron again. First of all, let us evaluate a curl f. For evaluating curl f, we need to determine this determinant ijk, del by del x, del by del y, and del by del z. Coefficients will be taken 2x square minus 3z minus 2xy minus 4x. Now you can evaluate the curl of this. Obviously it will be a vector quantity, and you can explain like this: I cap this into this. The derivative of this term with respect to y will be there, and it come out to be 0 and minus, and this minus will be plus. Derivative of this with respect to y, so that come out to be 2x. So ultimately what we have, that is 2x will be there, minus j cap. Derivative of this term with respect to x minus 4, and derivative of this one is z. Sorry, it is wrongly written x, y, z. So this into this, derivative with respect to z, that will be 0, because there is no z term involved here. So derivative of this term with respect to x is minus 4, and derivative of this term with respect to z, that is minus 3. But minus of determinant will be there, so that will be plus 3. And the plus k cap will be used. This one we will expand along this. So derivative of this term with respect to x minus 2y, and minus of this derivative with respect to y. No y term is there, so this is 0. So ultimately what we have, j cap minus 2y k cap left with us. So this is a vector, and you can take the value, that is j cap minus 2y k cap, and this will be written over here, that will be dx dy dz, because in place of dv we can write down like this. Now let us write down the limits as we have written in the previous question. The equation of tetrahedron is given, so that is 2x plus 2y plus z is equal to 4. and x equal to 0, y equal to 0, z equal to 0. Lower limit is clearly 0 in all cases. You can write down the limit of either of x first or of y first or of z first. You can change, you can make your own order. Whatever order you are making, the question will always be correct. So there is no doubt about that. So if I take the limit of x first, we will have 4 minus 2y minus z upon 2. So this should be the upper limit, 4 minus 2y minus z upon 2. So this is the limit of x. Okay. Now you can take the limit of y. So for y, we need for y we have to take x0. So if you take x0, you will have 2y plus z is equal to 4. So the limit of y will be 4 minus z over 2. So we can take 4 minus z over 2. So this is the limit of y. At last you can integrate with respect to z. So y will be 0, z is equal to 4. So this is the upper limit. Now you can integrate in this order. First integrate with respect to x, then with respect to y, then with respect to z. Clearly, this will be a vector quantity as I said. Because we are evaluating the curl, and curl is always a vector quantity. So this is the way to evaluate the triple integral. Now you can evaluate this. And I will complete one step, that is 0 to 4, and that will be 0 to 4 minus z over 2. Ultimately, what will be its integration? That will be xj minus 2xy k into dy dz, and the limits will be used. There will be 0 to 4 minus 2y minus z over 2. Now you can put the limit 0 to 4 minus z over 2. Now, what will be the upper limit we have? The upper limit is this. So in place of x, you can substitute 4 minus 2y minus z over 2 into j cap, and minus 2y into 4 minus 2y minus z over 2 into k cap. At last, the differentials will be written. The left with us, they are dy dz. 2 will be cancelled, and now you can integrate the remaining terms with respect to y. So 0 to 4, when you integrate it, what is left with us? That is 4y, its integration. Its integration will be 2y square over 2. So 2 will be cancelled, that is a y square minus yz over 2 into j cap, and in circular bracket minus its integration 4y square over 2. So that will be 2y square. 2 will be cancelled, minus and minus will be plus 2y cube over 3 plus y square z over 2. Y square z over 2 will be done. So now plus will be there because minuses are just inside, and this term should be negative. So this is into k cap, and the limits will be substituted. At last we will integrate with respect to z. The lower limit is 0 and upper limit is 4 minus z over 2. Now you can substitute 4 minus z over 2 in place of y, and simplify it, and at last integrate it with respect to z. So this is the work which we have to complete. So one step I left here, we will complete it at home. So this is the procedure to evaluate the triple integral or volume integral. So all these types of integrals will be used for the proofs of simplifying the questions of Gauss divergence theorem, Green's theorem, and Stokes theorem. So we shall do in the next class the theorems, and we shall use these integrals. Thank you very much. Any question?